Hey everyone, today we'll be looking at another derivation. So this is a not very common derivation. I found it somewhere, and it's going to derive two formulas at the same time. I just thought it was very convenient and very easy to follow. So it's a derivation of trigonometry. The formulas for sine A plus B or sine alpha plus beta and cos alpha plus beta. So it goes like this. Say we have a rectangle, and this rectangle has one of the vertices, a line coming from one of the vertices to somewhere in on the opposite side of the rectangle, and that line is 1 unit. Then we'll name this vertex A, this one B, this one C, this one D, and we'll call this one E here, and this will be F. So once we've done this, we see that we have a right angle triangle with its hypotenuse as 1. Then we have these two angles here. The first one, the blue one, is alpha. And when this is alpha, this means that this one will be 90 minus alpha. And this one will be beta, meaning that this one will be 90 minus beta. Then, since these two added together, it's alpha plus beta with alternate angles. Since this is a rectangle, this means that this will be alpha plus beta as well. Then, if we go to this triangle, we see that we have 90 minus beta here, and this is also 90. So this means the sum of these two is 180 minus beta. So for this whole thing to be equal to 180, because it's a straight line, it means this one must be positive beta. This angle is beta here. Then when this one is beta, it means this one is 90 minus beta. So we have all the important angles. We can also find this angle here, but we won't need it, so let's leave this one. Now, in this right angle triangle, since we have 1 unit given and it is the hypotenuse, this means that if we say cos of alpha, it will be this line AE divided by 1. So this means that this line is simply cos alpha. Then the same thing with this line here. If we say sine of alpha, it will be Fe over 1, which means sine of alpha is equal to Fe. So this is sine of alpha. Then in this triangle, we also have a 90-degree because this is a right rectangle. We have this hypotenuse, which means we can find what this angle is, this side is in terms of this angle. So the sine of alpha plus beta will be this dA over 1, which means this dA equals to sine alpha plus beta. Same goes for dF. If we say cos of this angle, we'll say it's dF over 1. So that means this one is cos alpha plus beta. Right, now we're left with finding these other smaller sides. But before that, let's come to this side. We see that in triangle ABE, this triangle, if we say what sine beta is, sine beta will be BE over AE, the opposite over the hypotenuse. Substituting this cos alpha here, we get BE over cos alpha. Multiplying both sides by cos alpha, we get BE equals to cos alpha sine beta. Then let's put this where BE is. Now we come again in triangle ABE. We say, what is cos of beta? Cos of beta will be the adjacent side divided by the hypotenuse. So that's AB over AE. Substituting our AE, since we already have AE, we get cos beta equals to AB over cos alpha. Multiplying both sides by cos alpha, we get AB equals to this. Then we will bring our cos alpha plus beta here. Cos alpha beta, cos alpha, cos beta here. Then we go to the last triangle. In FCE, we say cos beta is CE, cos beta is this side divided by this side, FE. And FE is already found to be sine alpha. We can put it in here. Then multiplying both sides by sine alpha, we get CE equals to sine alpha cos beta. So it means where the CE here, we come and put our sine alpha cos beta. We do the same thing again in the same triangle to find FC. We say sine beta equals FC over FE. FE is already found as sine alpha. We substituted it in. We multiply both sides by sine alpha. We get FC equals to this. Then we go and put sine alpha, sine beta there. Now, what have we accomplished? We've accomplished that this shape ABCD is a rectangle. So a rectangle, opposite sides are equal. So this means we can say sine alpha plus beta, which is this side, is equals to the sum of these two. So sine alpha plus beta is the same as these two added together, which is our formula, first formula. Then if we go to the other sides, the other pair of opposite sides, we see that cos alpha plus beta plus this sine alpha sine beta is the same as this one, AB. And if we put it nicely, we take this term to the other side, we end up with the formula for cos alpha plus beta. So this is a nice derivation that simultaneously finds the formulas for sine alpha plus beta and cos alpha plus beta in a very smart way, in a very clean way. And then I think this should be taught or be shown to learners. I thank you very much. Please subscribe for more videos like this and comment, and I'll see you in the next video.